Thank you very much. It's great to be here. Now this is going to be like, it's Friday night, everyone's had a couple of drinks, and it's been a super dry talk on game economy design and Web3 viability, sustainability. No, we're going to keep this super light, and I'm afraid those of you in the front seats, you've let yourself in for it, because I am going to ask for audience participation. It's going to be that much fun. Right, so what I'd love to see is a show of hands. Who here is involved in game design in some way? Lots of hands, good. Who has had one of those ridiculous spreadsheets that you've tried to use to understand progression systems and game designs and level progression? Has everyone seen one of those horrible things? Good, lots of hands. We're here to give you a new way of doing game design, which is Machinations. It's been around for a few years. We've got about 40,000 people using Machinations to design their games. So what I'm going to do today is give you a quick crash course in what Machinations is, what it does, and more importantly, how you can use it to improve your game designs and get a better understanding of how your game designs come together. And when you make some fun little changes in your game balance, what you can do to test them and streamline that process. All in 20 minutes while I'm kind of balancing a mouse almost erotically on my thigh. David here is going to be helping me drive Machinations as we go through here. So I was trying to work out how I could balance a microphone, a mouse, a laptop, and not stand in the way of the screen. So David's going to help me out by helping me drive Machinations. So this is Machinations. This is the platform. You can go to machinations.io, create a free account, and start using it without any barrier, and start picking it up. It uses these symbols down the left-hand side here to create any type of game logic. And so the idea is that by using these objects, you can start to simulate progression systems and mergent systems so that you can understand how players could actually interact with your game and what their experience is going to be, how quickly they're going to get through certain areas, how much health they might need, or any type of mechanic. So I'm going to start off, and I did say we're going to kind of live hack this as we go through. First object I've just dragged on there, so this is a source. This little pointy up triangle, and sources create resources onto our canvas. But we've got to have somewhere for those resources to go, so I'm going to add a pool here and create a little flow diagram. Now the important thing about Machinations is once we created this little flow thing here, we can hit play with it and actually see our lovely resources moving around on the screen if our internet connection still works, and we can actually see resources moving around and we can start to create some logic. So what I thought we'd do is we'd start talking about some kind of resource gathering game, some way that players are going to come in, they're going to create some kind of harvester. I've been playing Dune recently, so I'm probably thinking some kind of Dune harvester that's going to go out there and start collecting resources for us. So this, I'm going to have David label this for me. Let's call it spice. Let's just completely rip off their ideas. Perfect. Hit return for me. Sorry. Thank you. Now with that spice, we're going to use this to buy some kind of harvester. So if you could put a 5 in there for me. Perfect. Now, what we've got now is we've got our spice is going to be gathered. And just label that one harvester for me. So we've got some harvesters that are going to be created. This little symbol here, this is our converter. And what this does is it takes any number of resources and it converts it into another number. It's not imaginative naming, there's nothing complex here. I'm going to make that automatic, so it's going to take 5 resources, it's going to convert that into 1 resourcer. But now what I want to do is I want to create some kind of feedback loop with this. So the amount of spice that I'm going to collect now as a player is going to go up because I've got more harvesters. We're going to do that by grabbing one of these. This is a state connection. So I'm going to drag this state connection from my harvester pool to my connection here. And so for every harvester I have, and I'll start the simulation again, for every harvester I then get, I'm going to increase the amount of spice that's being produced. So now we've got one extra harvester, we've got one extra bit of spice being produced each step. Now immediately, those canny folks of you out there that can do a bit of maths will notice that this is going to go exponential pretty quickly. And actually we're going to start really ranking up the amount of spice that's being produced, and it's going to kind of be no good. And this is where audience participation is going to come in. So all of you lovely game designers out there, we've got this system where it's going exponential. What sort of mechanic do you think we could introduce to this game so that it's not going exponential? So we need something else that's going to drain away our spice for something else. Has anybody got an idea? Rob?
Harvesters break down.
Harvesters break down. Love it. So what we're going to do is we're going to put something else in here. I'll zoom out a little bit. And I'm going to add a drain to this. So this is a drain. Drains remove resources from the canvas. So if we've got too many resources, we want to get rid of them. I'm going to add a drain to do this. And for this purpose, I'm going to add one of these. Now this is a gate. And we use gates to create randomness, and we use them to create different types of probabilities of things happening. So I'm going to make this automatic random. So how often do you reckon a harvester should break down and get removed? Like 20% chance? Yeah.
Yeah, why not?
Just go with that, yeah. So if you put a 20% in there for me, David, beautiful. So what we've now got is this will now trigger our drain, and this will then, when the drain gets triggered by our gate, we're then going to remove it. So if you want to stick a label on that for me, David, of broken down. Well, we've got bad Wi-Fi to make this even more challenging. Good. Let's make sure, give that a second. Talk amongst yourselves. So, hopefully when this starts running, I'll ad lib now. I'll make something else up. So, when this, it's going to run. It's going to run. Let me reload it. Track it. I'll reload it. Right, so you can see that this is the type of process that you go through with Machinations, which is you can take something really, really simple, and using this visual language, you can start to build up the logic so that you can really start testing out progression systems and understanding how this is going to work. If you have an internet connection, it's often 20 to 30% more efficient. But so we can go from something simple like this, and if the internet was working, I would carry on adding more logic to this. What's the beauty of this is you can think it's going to be really complicated and difficult to learn, but actually just that simple process, that's pretty much how all of Machinations work. You start off with what the player journey is going to be, what a player is going to be doing inside the game, and you carry on adding logic to it all the time. And this is where we can then get to something like this, which is slightly more complex. So this is the same sort of thing, which is then enabling us, here we're simulating an endless runner type game. I'm going to be really brave and see if we can run this model somehow. And what we can then do is really start to understand how players' progression could go through a system like this. So here we're not just simulating something very simple. We're simulating the entire player journey, going through multiple games, multiple sessions of an endless runner session, understanding how many games they're going to have, how many coins they've been rewarded, and even looking at where are they going to drain those coins? What are they going to spend the coins on? How many sessions are they going to have to play so that they can unlock everything, all the skins or any other items in the game? We can then layer onto this in-app purchase systems, different types of game logic, so that we can really start to understand what's a player's journey going to be as they come through a system. If you have a player who's then going to do all of your in-app purchases and buy everything they possibly can, well, are they going to run out of things to do in your game? And this is what we can then start to test inside Machinations.
Quick question.
Yes.
Can you build it sort of like a more abstract level? Can you define like a module which has its own contained logic and then just reference a higher level instead of going through all the detail?
Yeah, absolutely. So there's a few ways we can kind of do that. So in here we've got layers, so we can then turn off the layers that we want, just focus on the key systems or key mechanics that we want to, or we can group them, we can do all sorts of things to kind of really help identify what the core mechanics are, and how we're going to use them for our gameplay.
Okay.
Great question. As I mentioned, Machinations, we've got about 40,000 people using Machinations to do their game design processes, ranging from Microsoft, Ubisoft, Paradox, all sorts of companies using the platform to help them get their game economies ready. Inside our community, I don't know if this page is going to load because it's quite heavy, but there's over 30,000 game designs that people have built and shared across the community. So if you're looking for inspiration for your mechanics, rather than having to start from scratch, you can come in and have a look at how other people have designed the mechanics and how other people are approaching the sorts of challenges they have in just about every genre of game. Inside Machinations, we also have a huge number of templates. And I was talking to somebody earlier about kind of level progression systems. We've got a huge number of templates that kind of walk through and show how different games have handled progression systems. So if you're looking for a leveling up mechanic, rather than having to think about something from scratch, you can actually come in and see these models, see how they've been constructed and what the type of logic is behind these progression systems so that you can build this into your own game. Pause there for a moment if there are any questions. Okay, let's see if this...
No, there is one. Do you know, can you say which Paradox game is using Machinations?
Yeah, so actually there's quite a few of them that are using Machinations. The key one, the one that I know about, and the weird thing is we can't see what people are making on Machinations. So Paradox are quite secretive about what they build. So we only know about a couple of them. I know the Crusader Kings, they've been using Machinations. One of the most ridiculously complex progression systems there are in any game. There's lots of different currencies, there's lots of different ways you can go through the game. But it's a really, really interesting model.
That's really cool. I know a couple of people who work at Paradox, so I'll ask them about how
Yeah.
Yeah, it's really exciting.
So let's see if this is now working. We've got this. Yes, great. So we're collecting spice. We're going to convert this into more harvesters. We've now got a 20% chance of these harvesters breaking down. And it's just happened again. We're going through the harvesters quite quickly. At 20%, if we're only collecting one spice a step, it looks like it's still going to be slightly exponential. So any other ideas that we could add into this model to make it less exponential?
Sandworms.
Sandworms, yes. And sandworms could destroy a lot. So again, we could do the same type of construction. And here I'm then going to have do that again, another gate, another state connection to my drain. Let's put it at a much smaller percent. Let's do like 10%. And this time, right in here, let's have a sandworm wipe out all of our harvesters altogether and reset it. One thing I should add here is wherever you're seeing this dice symbol, this is where we're using Monte Carlo statistical analysis. Whew. Friday night, good. So, hands up who's heard of Monte Carlo before, as in not the place, as in the statistical analysis. So, if you go into a spreadsheet and you say, right, a player's going to flip a coin 10 times in a row, a spreadsheet's going to tell you, well, it's 50-50, therefore you'll have 5 heads and 5 tails. In the real world, when you flip a coin 10 times in a row, you very rarely get perfectly 5 heads, 5 tails. The chances are you'll get a whole range of different results. And that's what Monte Carlo does inside Machinations. So the whole idea here is when we've got a 10% chance of something happening, it doesn't mean precisely once every 10 steps it's going to happen. It means that every step there's a 10% chance of that action taking place. And this is a really important part of understanding emergence, understanding game probabilities, which is just because you've got something that can happen 5% of the time doesn't mean it's going to happen 5% of the time. It means that every time it's possible, there's a 5% chance. And that might be deep for a Friday night after a couple of drinks, but I'd thoroughly recommend if you're ever building a game progression system, you're ever looking at odds, looking at drop rates or anything inside your games, understanding Monte Carlo is one of the most important things that you can do to really understand odds. And if you want to learn more about Monte Carlo, come and have a look at Machinations, grab a free account, start coming in and learning a little bit more about it. If you would like to know more about Machinations, please do come to our YouTube channel. There it is, where we've got hundreds of videos now that kind of walk through, explain how Machinations work, everything from our really introductory sessions for our 101, which goes through and explains how each of the different objects work and how you can use them inside your models, all the way through to some more complex sessions where we're looking at things like automated market makers. So if you're interested in Web3 games and understanding tokenomics, token values, I'd really recommend understanding that AMM model session, where we literally walk through and build an AMM inside Machinations and then show how it works to help you understand it. Any other questions that anybody has? Yes, right at the back.
How does your monetization work?
So the way our monetization works, that's a great question, thanks for that. Leading me straight onto a sales pitch, brilliant. So the way in which it works is we do have a free community model. And the way in which what that means is that if you come into Machinations and you start building out some models, it's completely free, but any models that you built are building in public. That means that through our community, anybody else that's in the community can then go through and see what you've built. Really helpful because it means we've got a huge community of people developing these who are willing to share their models. If you do want to have your models private, you can then go into one of our paid plans. It starts at $59 and ramps up from there depending on how complex and how large the simulations are that you want to build. Thanks for the brilliant question.
Yeah, right.
Good. Any other questions? Then I'll let you get back to the bar.
$59 for what time period? It's like monthly, yearly?
So it's $59 for a month, but that gives you an unlimited number of editors. So if you've got 10 people in the team, 100 people in the team, $59 gives everybody in the team access to that license.
And sorry, are there any other restrictions on what the complexity of what you can build on the free version?
Yeah. So really, when you're in the free version, you get a certain number of components. So I think you can have up to 300 objects in a single model, which is quite a lot.
Yeah.
I mean, most of the models that we see people building, especially for kind of a fairly simple game, well below 150 odd objects. If you're building a very large, complex Web3 economy and you need to model tens of thousands of simulations, you'll probably need a larger license to kind of simulate that. One of the things I should mention is when I hit batch play on this model, when I hit that, it's taking the model, it's sending it up to the cloud, it's then running multiple parallel streams of that simulation in the cloud, and then firing back the results. So when you start running tens of thousands of simulations, it's using a lot of cloud time, which is where we have to cover our costs.
And how do you map this back to something like game player hours and clock sort of game player hours, or complex probabilities at the end of some logic tree that tell you, okay, there's a 20% chance of the player ending up in this state. Is that something you can quickly demo or explain?
Probably that's a very complex question, right? The key thing with Machinations is there's this whole concept of time. So we're always talking in steps, and now that one step can mean absolutely anything you want it to. So that one step could be 1 day of gameplay, it could be 1 session, it could be 1 second, or even we've got people that are simulating and balancing first-person shooter games where 1 step equals 1/100th of a second. So it's all kind of about building the logic that you want, and because it's a Turing complete system, there's no limits to what you can build with Machinations.
Okay, awesome.
Perfect. Thank you very much. And so, if anybody has any more questions, me and David will be around for a while. Love to chat to you and talk to you more about game design processes in Machinations. It's always fun.